Hi, welcome to another video short on limits. This is in fact example 6, and boy do I have a great limit for us to look at today. This guy involves square roots. In fact, square roots minus square roots. But before you get busy with any limit, the first thing you should do is always look at the value that x goes to and substitute that into the expression to see what type of number you obtain. So we will substitute 3 in for x. We will do some house cleaning and some simplification, and we obtain 0 over 0. This is in fact an indeterminate answer, which just is a polite way of saying you will be using algebra to assist you in evaluating this limit. Now, besides 0 over 0, there are other indeterminate forms to be careful about, and that would be 0 times infinity, or infinity divided by infinity, or infinity minus infinity, 0 to the 0, infinity to the 0, or even 1 to the infinity. So let's go back to our expression. Now, it is always a good idea to try to get a picture of what variable or what variables will cancel out that 0 over 0. And the best way to do that is look for some advice from the value that x goes to. So in this example, x goes to 3. So treat that arrow like an equal sign. And if you do that, you are allowed to bring the 3 over to the other side. So x goes to 3 is equivalent to x minus 3 goes to 0. And there's the 0 that we would like to cancel out. So hopefully we'll have an x minus 3 somehow hidden in the numerator and an x minus 3 in the denominator, which is obviously right there. And so we have to come up with a technique to simplify those square roots in the numerator. Now, if you ever get square roots plus or minus some number, or square roots plus or minus square roots, as in this example, the mathematical technique that you should look at is multiplying by the conjugate. Now, if I have a term, for example, a minus b, its conjugate would be a plus b. Likewise, a plus b has a conjugate of a minus b. So in this example, we have a subtraction. So if I look at a minus b and I multiply by its conjugate, a plus b, I also have to divide by a plus b because I do not want to change the answer. Because when I multiply by a plus b over a plus b, it's equivalent to multiplying by 1. So it will not affect the final answer. So in this example, we have the square root of x squared plus 7 minus the square root of x plus 13. Its conjugate is going to be the square root of x squared plus 7 plus the square root of x plus 13. So I'll multiply and divide by the conjugate. The advantage of using conjugates with square roots is when I multiply square roots by square roots, the square roots disappear. So a nifty little technique when you're multiplying square roots by their conjugate is look at the first term, which is the square root of x squared plus 7. You square that, and you just come with x squared plus 7. The square root disappears. My second term, which is the square root of x plus 13, when I square that, the square root disappears, and I just get x plus 13. Now stick brackets around these beasties, and then stick a minus sign in between. And we get an expression that's easy to simplify. So let's do some house cleaning. We get x squared minus x minus 6. This we can factor. And lo and behold, we obtain our x minus 3 in the numerator and our x minus 3 in the denominator, as we hoped we would. So let me just rearrange, cancel out those beasties, simplify. We can now substitute 3 in for x, do some house cleaning, more simplification, and we attain the answer 5 over 8. So the limit of x goes to 3 of the square root of x squared plus 7 minus the square root of x plus 13 divided by x minus 3 is 5 over 8. And we obtain that answer by multiplying the expression by the conjugate of x squared plus 7 minus square root of x plus 13 on both the numerator and the denominator. Thank you.